Welcome back to our grade 11 maths lessons. I'm Miss Awinu, one of your maths teachers. In our last lesson, we looked at the length of vectors. In today's lesson, we are going to look at how to subtract and add vectors. All right. Before we get into that, one term that we are going to be using right throughout our lesson, okay, the resultant vector. All right, resultant vector. Now, what is the resultant vector? It is the length and direction of a vector needed to complete a triangle, okay? It is the length and direction of a vector needed to complete a triangle. So we call this the vector law of triangles, okay? And we're going to look at how we apply this vector law of triangles using a Cartesian plane, okay? So let's look at example number 1, okay? Example number 1, and we're going to draw very quickly a Cartesian plane. Okay, now from our Cartesian plane, we can find the x and y components. Okay, so vector C, we're going to add these together. All right, vector C is equal to vector A plus vector B. All right, so we'll get the x and y components from this graph. All right, so we have vector A, x and y components are 6, 2, okay? So we write that in matrix form, 6, 2 plus vector B, x and y components are 4, 3. Okay, again, we write that in x and y components as a matrix. All right, so we have vector A plus vector B. What is the length of, or the x and y components of the resultant? We simply add, all right, the vertical components and the horizontal components. So 6 plus 4 will give us 10, and 2 plus 3 will give us 5. So now that we have the x and y components of the resultant vector, we need to find the length and direction. So we're going to use this resultant here to find that length and direction, okay? So we apply Pythagoras to find length. So vector C, okay, vector C is equal to the root of 10 squared, all right, plus 5 squared. 10 squared is 100 and 5 squared is 25, so that gives us a total of 125. The square root of 125 is 11.1, okay? So the length of vector C, or the resultant vector, is 11.1 units, okay? We have found the length. Now let's move into finding the direction of that vector. We apply trigonometry here, and we're going to use the tangent ratio. So tan theta is equal to, using the matrix there, tan 5, we have a fraction of 10 divided by 5, okay? Now at this point, you are supposed to be using your calculator, so theta is found by dividing this one here, and I'll write this out for you, okay? Divide 10 by 5, okay? You get your answer, and you press the shift button, okay? Find your tangent button on the calculator, so shift to 10, and that should give us the answer, okay? So what is the answer here? 10 divided by 5, answer shifted to 10, is equal to 63.4 degrees. Okay, 63.4 degrees. All right, so that's how we find the value of the angle, which is the direction of your vector. Okay? Now, very similarly with subtraction, you use the same idea. We need to have the x and y component of the resultant before we can find the length and the direction of your vector. Okay, so let's have a look at example number 2. Now, example number 2, let's say we have vector A, which is equal to 1, 4. Okay, 1, 4. And we have vector B, which is equal to 5, negative 1. Okay, let's subtract these vectors and see what our answer will look like. Okay, so we have vector A minus vector B, and this is going to give us the resultant vector. Okay, so using the matrices here, 1, 4 minus 5, negative 1. Okay, 5, negative 1. This is going to give us a resultant of negative 4, 5. Okay, negative 4, 5. So that's our resultant vector. Okay, same idea here. Instead of adding, we are subtracting. So 1 minus 5 is negative 4, and 4 minus negative 1 will give us positive 5. Okay, now if this was on a Cartesian plane, let's see how this would look. All right, let's see. Okay, our first vector is here, 1, 4. The next one is 5, negative 1, which is going to be down here. So vector A, vector B, okay, and the resultant vector is going to be in this direction. Okay, so there's our resultant vector. Right, now we are going to now use Pythagoras to find the length of the vector. So our resultant vector here is equal to square root of negative 4 squared plus 5 squared. Okay, that's going to give us 16 plus 25, which is 41. So root 41 is equal to 6.4 units. All right, so there's your length for the resultant vector here. All right, now we are going to apply the tangent ratio again to find the direction of vector or the resultant vector. Okay, so tan theta is equal to negative 4 over 5. Okay, negative 4 over 5. And again, you're going to do exactly what we did here. You divide negative 4 by 5, get your answer, shift to tangent, and your answer, theta, should be equal to negative 51.3 degrees. Okay? Now, why is this negative? Because our answer is lying in the fourth quadrant here, where tangent will always be negative. Okay, now this is something that you are going to cover in some of your next lessons, not with me, but you will come across this. Okay, so hope you have learned something good here, and this lesson has helped you. In our next lesson, we are going to look at how to multiply vectors. I hope you can join me then.